So IP is connectionless, not reliable. It is unreliable. That's why you have told in the very earlier classes of IP. So what IP says? So IP always use a best delivery effort. So our best effort service. It will try its best to deliver your packet, but cannot give the guarantee because it is connectionless. So if it is connectionless, so let's talk about, let's say, a originator machine. This is my source machine. Wants to send a packet to the destination machine. Now, so they are connected via certain routers. Now let's say, so this machine sends a packet first to the router R1. This is router R1. This is router R2. Now router R1 send the packet to router R2. So something goes wrong at router R2. So that's why the packet is dropped at router R2. If so the IP protocol is connectionless, how my originator could able to know about this? So whatever packet I have delivered to the destination, so could not able to be delivered. So in this case, so if I could able to inform, so this router could able to inform, so this originator that is something has gone wrong with your packet. That's why I dropped your packet. That is a better way to go and know at the source or originator end. So that is something has gone wrong with my packet. So let's do some repair on top of the problem that has occurred at the router R2. So that is, so this router R2 must inform back, give the feedback. So to the originator, there is something gone wrong. But originally it was not in IP protocol, because IP protocol is connectionless. It does not provide any service through which you can able to know the error. So that's why to make the correct the error. So that's why IP protocol is initially connectionless. So this type of facility of giving the feedback to the originator is not available in the IP protocol. So we need a companion protocol. This is a companion protocol. This is a companion protocol. That's why we need a companion protocol on top of IP to avail this opportunity or to avail this mechanism, that is the feedback mechanism, or it is called as a error reporting mechanism. So this error reporting mechanism is facilitated by the companion protocol, that is ICMP. ICMP, that's why if I understood this, so what ICMP provide, so by using this ICMP protocol, we can able to give the feedback, or we can be able to report the error back to the originator, so that originator can take the respective measure or action. So on top of it, so to do the communication in the next step. So make it what happen, or make it so erroneous, free out of error. Okay. So that's why ICMP is the protocol. So that is going to do error reporting. So that's why the first kind of functionality. If I look into the functionality. So what ICMP needs to provide, the first and foremost important functionality, so ICMP has to provide is error reporting. Error reporting. It has to report the error, because IP protocol originally does not have the capability to report error, because it is connectionless, unreliable. So that's why a companion protocol is being added on top of IP to carry out this task of what? So reporting the error, that is ICMP. And this full form of ICMP protocol is Internet Control Message Protocol. So as it is rightly mentioned, control message, it is giving a control message back. So that is something has gone wrong. It is not supposed to carry some data. It is basically used to exchange control message, thereby reporting the error to the originator. So when something goes wrong, during the data communication in the intermediate routers. Okay, so that is the first and foremost functionality of what? ICMP protocol. Then along with that, one more functionality, additional functionality, it also it not only support error reporting or error type of message. So it also can be used for another purpose, that is called diagnostic purpose. Diagnostic purpose. So what I mean to say, diagnostic purpose. Okay, let's. That means, so by using ping, you are checking whether there is a connectivity. Let's say I want to send a packet from the source machine to destination machine. Before any communication to happen, if I could able to check whether this destination is reachable from my end or not, whether there is a network connectivity available within me and that particular destination or not. If I want to do that, I can use this ping command. Do you know how ping works? Ping works by using this ICMP protocol. Okay, so whenever you send a ping command, whenever you type ping and the IP address of the destination, so behind the scene, so what happens? A echo request message is generated. Okay, that is the ICMP message. And so when the echo request message is generated by the source end, so whenever it is reaching at the destination end, if at all it reaches, so then the other end is going to send back a echo reply message. That means echo request message is generated by the originator. So when the destination machine receive this particular echo request message, so as a consequence of it, it is going to generate a echo reply message. So if the echo reply message is received at the source end, so then now source could be able to understand, yes, there is a connectivity from my end to the destination. So therefore, we can go and do the communication. So that's why this is one diagnostic purpose. For diagnosing, so whether there is a network connectivity available between me and my destination, so I can use this ping. This is one example. There is another example. We'll talk about later on, trace route. There is another important example, trace route. We'll talk about later on. So just hold on for that. Okay. So trace route. This is another. Another ICMP message which can be used for again diagnostic purpose. That means there are basically two purpose or two functionality. So provided by a ICMP protocol. One is error reporting, and along with that, it also can be used for diagnostic purpose, like the example I have given. Okay, so this is what is the functionality of a ICMP protocol. First, try to understand. Now, let's look into how the ICMP message, where it is going to fit it into. Okay, so if I think of, let's say think of an IP datagram. Think of an IP datagram. Let's say this is my IP datagram. This is my IP datagram. In the IP datagram, what is there? In the IP datagram, so it is the IP header plus the payload. Yes. So in the IP datagram is consisting of IP header or the network layer header along with the payload. Can anybody tell me what are the possible payload as far as the IP datagram is concerned? A payload can be what? What are the possible payloads for a IP datagram, if you understood correctly? A TCP segment. The payload can be a UDP segment. Right? So this payload as far as the IP datagram is concerned, so it could be a TCP segment or it could be a UDP segment. So how do I know? So let's say one IP datagram is received at a recipient end. मान के चलिए, so now at this end a IP datagram is received. So by looking into what, it would be able to understood whether my payload is a TCP segment or whether it is a TCP segment. Okay, so the protocol value is 6 means it is a TCP segment. If the protocol value is 17, that is a UDP segment. That we have already discussed and you must know it. Okay, that is, so in the IP datagram, the payload can be a TCP segment, the payload can be a UDP segment, and the protocol field is going to tell me whether the payload is a TCP segment or UDP segment. And remember one more concept here. So the payload can be a TCP segment, can be a UDP segment, along with can be a ICMP message. Right, understood here. That means, so where the ICMP message is going to go? The ICMP message is going to go inside an IP datagram. That means the ICMP message is encapsulated inside an IP datagram. That is, the payload of an IP datagram can be either a TCP segment or can be a UDP segment or can be a ICMP message as well. So that is how I could able to know. So whether it is a TCP UDP segment, you already know. How to know it is a ICMP message? In that case, again the protocol field has to be checked. If the protocol field value is 1, so this is a ICMP packet. That is the payload part of an IP datagram is a ICMP packet. Try to understand this first. So a IP datagram is consisting of the header plus the payload, where the possibility of payload can be a TCP segment, can be a UDP segment, or can be a ICMP message. So depending on the protocol value, the receiver could able to understood so what type of payload now it has come within the IP datagram. Everybody clear? Now, so once we understood where this ICMP message is going to carry, so inside a IP datagram, so then we have to, okay, one more concept, one more illusion. Sometimes it is a illusion. Okay, so we can say that conceptually, if you think of, if something is in payload, मेरा IP datagram में, so मेरा payload है. Payload मतलब either it may be TCP or maybe UDP. So as far as I look into the, if I look into the protocol stack, back, this is my application layer, this is my transport layer, this is my network layer, this is my data link layer, this is my physical layer. So when I talk about a IP datagram, we talk about the network layer, right? So we call a packet as a datagram in the network layer. So then I say payload. Payload is my TCP or UDP. That means that TCP, UDP, whichever is the payload, is a upper layer protocol, right? Are yes or no? So whatever payload so is available in the IP datagram, so that becomes a part of the upper layer. So that is become a part of the upper layer protocol. But so even if ICMP is a payload, part of the payload of IP datagram, so but actually it is not a part of a upper layer protocol transport layer. It is in the network layer. So that is a special case. Try to understood. Okay, you don't be in the illusion that ICMP is in the payload part of IP datagram. That's why it is a transport layer protocol. No, it's not a transport layer protocol. This is a special case where a ICMP packet is being encapsulated within an IP datagram. But as for the concept, it should be the upper layer protocol, but it is not. It is a special case. Rather, it is a part of the network layer. That you try to understood. Okay. Now let's look into the message format. If anybody has any doubt on this, you can ask me, stop me. Okay. So now let's look into the ICMP message format. ICMP message format. What will be there? Because we understood kahan par mera ICMP message aayega. So in the payload. Now, what will be there exactly in the ICMP message? Let's try to understand. ICMP message format. Okay, so as far as the ICMP message format is concerned, it looks like this. So very simple, not much difficult. So if I take it as 16, 8, so 0, 8, 16, 31. Okay. The first one is called type. Second one is called code. And third one is checksum. And the last one is data. Okay, so let's try one by one. So what is there in the ICMP message format? Very simple. So first is type. So the type of ICMP message is going to tell what type of ICMP message is going. See, when I say, so one ICMP, let's say I go and execute a ping command. So here in this example, I execute a ping command. A echo request message is going. That is one kind of ICMP message. Okay. So when a echo reply is coming, as a result of this echo request message, the echo reply message is coming. That is another ICMP message. So that is, so let's say, so for example, I send a packet. So from here to here, from here to here. Now this router has discarded this packet because the TTL has expired. TTL has expired. You have already know this concept. So the TTL. So when the TTL value is expiring, even if it is a valid packet, I have to discard this. So let's say router is discarding for this reason. So that is, in this case, it is going to send a ICMP message, TTL expired or time exceeded. Okay. So that is another ICMP message. Okay, so there are several types of ICMP message. How do I know? So for that sake, this type field is going to tell me exactly what type of ICMP message right now is being carried in this payload. Okay, then code. So as far as the code is concerned, this is a soft type. This is soft type. For example, one example I'm giving. Let's say the type is equal to 3. Sorry. If the type is equal to 3, so that is referred as a destination unreachable. Okay. So that means now what I'm trying to say is that, so let's say packet is being sent from here to here, here to here. When the router is supposed to deliver the packet to this final destination, so let's say, so this destination is off. Ye machine band ho gaya us time. Can the router able to deliver the packet? No. So in that case, what type of ICMP message is going to generate? The router is going to generate a ICMP message, destination unreachable. Now the destination could not able to be reachable. Okay. So that's why, so whenever the destination is unreachable, the type is 3. The value of type is 3. But so whenever I say destination is unreachable, there are various, so what possibility why a destination can be unreachable. Let me draw one more diagram so to explain this so that you can able to understood here. Let's say this is my source machine. So wants to send a packet to the router. The router is going to send it to the next router. Next router, let's say here is a network. It connects a network and there are several devices inside this network. Several devices inside this network. Okay. So now my packet has come from here to here, here to here. Okay. So now I want to send a packet. So from this to this network, but somehow the link is down. This link is down. The link to this particular network is down at this point of time. Can I able to deliver the packet to the network? No, na. Sure. That is also referred as a destination unreachable. But if I look into what is the exact reason of the destination unreachable, because the network is unreachable. That's why destination we could not able to deliver the packet to the destination. So that's why here the type is equal to 3 and the code, I don't remember exactly what is the code, but I will show you. So from the slide right now. So I think it is 0 or 1, something like this. If the type is 3, code is 0, I can say it is, so destination is unreachable because network unreachable. Network unreachable. Okay. The network is unreachable. That's why the destination is unreachable. So this is one example. Another example can be, let's say my packet has been delivered from here to here, from here to here. So the network is there. Okay. The link is there. But whenever it is trying to deliver the packet to the correct destination, so that machine, that particular machine is down. Or machine abhi band pada hua hai. So in that case, type is 3. That is the destination is unreachable. But what is the reason? So the reason is something else. It is not network reachable. It is host unreachable. So that's why the code is 1. Code is 1 means host unreachable. Unreachable. Maybe the code value may be different. I'm just giving an example. I don't remember exactly. I have to refer to the slide for that. But I'm giving an example. So code is equal to 0 if it is network unreachable. Code is equal to 1. It is host unreachable. That means so combination of these two, we could able to tell what is the exact reason. So why this particular packet has not been able to receive the destination. So this is another example. So that's why here this code field is a subtype. You can say it is a type is destination unreachable and subtype code is network unreachable. Another code is what? Host unreachable. Another code is let's say port unreachable. Another code is protocol unreachable. So there are several subcodes or sub-messages of this particular message type. So that's why this code can be used in that scenario. So that code may be used, may not be used. If there is only one, under a particular type, if there is only one message, so then the code is always 0. If under a particular type, there are number of messages, so then the code can be 0, 1, 2, 3 like that. So that is a subdivision of that particular type. Okay. This is where code field is going to help us. So then checksum. Already you know what is the purpose of checksum. The purpose of checksum is to know whatever data is being received in the ICMP is the correct information or not. So that you already know. It is very similar to the way we are doing for IP, we are doing for UDP and TCP. So don't look into that. So now look into the data part. What will be there in the data part? That is very important to understand. So for us. So as far as the data part is concerned, inside the data part, so the original IP header will be there. I'll tell, just I'm writing, then I will tell, so what I'm trying to say. Original IP header. Original IP header will be there, plus 8 bytes of the payload. First 8 bytes. First 8 bytes of the payload. Okay, so the data part of an ICMP message is going to be the original IP header. So that is from which the packet is received and there is error. So that is the original IP header will be populated. So then the first 8 byte of the payload in that particular IP datagram. So that is going to be generated. So let me draw a diagram to make it explain. Then I'll tell why it is required to like this. Okay. So let's look into this. If I look into this diagram, let's say the source IP address is source IP address. This is, let's say, source machine. This is destination machine. This is router 1. This is router 2. Based on this, let's try to understand. Okay. So now, source IP address is source IP address. Whenever the packet will be generated, it will be generated with the source IP address of this. That is SIP, let's say. Let's shortly I called source IP address SIP. So then destination IP address will be DIP. That is the IP address of the destination. Okay. So now the packet is traveling. The packet has traveled from here to here, from here to here. Suddenly at this end, it finds some problem. It dropped the packet. Okay. So whenever it is going to drop the packet in the original IP datagram, so whatever is the header, like the source IP address is SIP, destination IP address is DIP, those are going to be populated inside this. So that means in this data part of it, what I say, original IP header will be there. Okay. What is the original IP header? So original IP header के अंदर source IP मेरा SIP है, destination IP is DIP and protocol जो भी वगैरह जो जितना, so 20 bytes of header, so that has come inside this packet, those 20 bytes of header minimum, okay, is going to be present here in the original IP header. So now the next question is, so the next part of the data part is first 8 bytes of the payload. Can anybody tell me what is the payload? First 8 byte of the payload में क्या होगा? एक IP datagram का first 8 bytes of the payload is what? You already understood that. What is the first 8 bytes of the payload as far as a particular IP datagram is concerned? Data link layer, physical layer. These are the 3 layers only available at the router. So that's why whenever router going to send back this message, it is going to populate with the network layer information, data link layer information, physical layer information. Okay, it doesn't have anything else. So whenever the packet is routed, so now packet comes here. A machine के पास आ गया, because network layer में he has told that destination IP address is the of this machine. So that's why now the packet comes back to this machine. But how it is going to be delivered to this process? ये ICMP मैसेज इस प्रोसेस के लिए है. सो कैसे मुझे अभी मेरा मशीन वो पर्टिकुलर प्रोसेस को डिलीवर कर पाएगा, इसलिए मुझे पोर्ट नंबर चाहिए ना. बट राउटर डज नॉट पॉपुलेट द पोर्ट नंबर इंफॉर्मेशन इन दैट पर्टिकुलर पैकेट. सो दैट्स व्हाई इनसाइड द डेटा part of it so populate the first 8 bytes of the payload where source port number will be there and the destination port number is there. Are you getting my point, what I'm trying to say? Are yes or no? Yes or no? So that's why the data part of it is going to have the original IP header जो packet में आया था, plus the first 8 bytes of the payload. So inside it, the most important information present is the source port number and destination port number, by looking into which, so my source machine can able to redirect this information to the higher layer protocols, or higher layer port number. So that is the port number of the process. So that now the process could able to know, okay, मैं ये packet भेजा था, now there is something wrong in this particular packet. That is the purpose of having the data where the first 8 bytes of the payload. So if you look into this type, there is a type 0. Okay, so type 0, code 0 means it is a echo reply message. Okay, so echo reply message का type 0, code 0, that you already know echo reply का काम क्या है. Okay, so try to just have a look into it. 0 0. So look into this. 3 is interesting. So in this case all are 3. Just a minute. Have a notation. So if I look into here, in all these cases, the type is 3. But look into the code. Code varies from 0 to 7. So 0 is for destination network unreachable. अभी अभी बोला था ना, I have told the correct one. So guess it, but correct one. So 0 is the destination network unreachable. So 1 is destination host unreachable. If it is specifically 3, destination port unreachable. If it is 4, fragmentation required, but DF flag is set. That we have already known. So if let's say there is a fragmentation required and the DF flag is set, can my router forward the packet? Router has to discard the packet, na? And then it has to inform the originator. So that is, I could not able to forward your packet. So rather I have to drop your packet because of this. And there is a need of fragmentation, but the DA flag is set. So basically, can anybody remember in which purpose? So this particular is used empty. Okay. So if I want to know what is the bottleneck empty of the path, so before any transmission happens, so as to what? So as to avoid the fragmentation in the intermediate routers. So then I could able to take the help of this particular ICMP message. So that is 3 and 4. That is type 3 and 4. So whenever you are sending a packet, so with DF flag set, if the router could not able to fragment your packet, then he is going to generate the ICMP message with a type value of 3 and a code value of 4. So that means whenever the receiver or generator of the packet is receiving this information, he could able to know, okay, so, and also along with this, he must also tell what is the MTU of his router, MTU at the end of the router, so that based on that, now you can go and divide the packet so that your packet can go and go and flow in the network without any fragmentation. So that is the reason why this ICMP message has been implemented here. Okay, this is one of the reality what we have already studied in the network layer. So this is another one, another code. So what is a destination network unknown, but this is no more used. So this is obsolete. Rather, we are using this one. Okay, instead of using this destination network unknown, so nowadays people are just using this destination network unreachable. Okay, so both the regions it is going to do that because there is not much difference between these two type and code. Okay, this destination host unknown. Okay, so this is the host is unknown. That means whatever IP address given to a system, so that is a bad IP address. So then you cannot, even if you go and try to deliver the packet, so that IP address is not known to the router, so you cannot able to deliver the packet. So that is a destination host unknown. So these are some of the type, some of the code. So let's look into some more type so as to understood. Look into here. Just a minute. Look into here. These are some more type. So type is 4. Code is 0, source quench. This is another important thing we have to understood. There is something called source quench. What is the source quench? Source quench means, let's say you are sending a packet. So at the router end, there is a congestion. So router could not able to deliver your packet because of congestion. So router wants you to, the sender, to slow down the sending of the packet. Then only it can carry your packet. At that point of time, so this is going to generate this kind of source quench messages. Okay, ICMP message should be source quench ICMP message. Okay, so that the originator could able to know, okay, so my packet could not able to travel because there is a congestion in the network. So as a consequence of it, I had to slow down the sending of my data. Thereby, so maybe it happened, I could able to so deliver my data to the other end. So this is another type of ICMP message. So then 5 and 0. If it is 5 and 0, then it is redirect datagram for the network. Redirect when the scenario of redirection is going to come. Let's say, for example, so if I talk about, so this is my source machine connected to a route, connected to a destination machine via routers like this. Okay, so this is my destination machine. Now let's say my packet is going and following this way to send the packet. So whenever it reaches at this router gives back me information that is, so you don't send your packet in this way, there is a better way available, so you can follow this path. For the timing, this path is better than this, so you follow this path. So that's why in that case, this router can go and send back an ICMP message that is a redirect datagram. So instead of following this path, so there is a better path available for your datagram to reach at the network or reach at the destination. So please follow that. So that kind of information is going to be provided by any router, so to the originator with the help of this type 5 and code 0. Okay. Now this is echo request. I have already told about this. 8 and 0 is echo request. 0 and 0 is echo reply. And this TTL expired. Just I was talking about. So this TTL expired. So this is the real implementation of this was trace route. I'll talk if time permits. At the end, I will tell you. So trace route. There is a trace route application like ping. If you want to check the connectivity to the other end, so there is another application called trace route. So to find the path, to discover the path, So what path exactly your packet is following while delivering to a destination? You want to know the path of it. So what are the routers in between coming to picture while delivering your packet? That you can able to find out by using this trace route application. Okay, there is a command in Linux, so that is trace route, or in Windows it is called trace RT. Trace RT. In Windows it is trace RT, and in Linux it is trace route. By using this, so let's say if you write trace route www.google.com, it is going to show number of intermediate routers through which your packet is traveling. So that the path of the packet communication is going to shown by you. So using this particular application. Okay, how it is going to do it? By using this TTL expert. I will just explain at the end how by using the TTL expert ICMP message trace route command could able to go on know what are the intermediate routers in the path as far as the communication is concerned. Okay, then this is a bad IP header. Nothing too much to tell. Okay, if something wrong in the IP header information you are populating, so that is another one is timestamp. So this is also used in, it is going to show you the round trip time. How it is going to show you? So for that sake, this ICMP message is going to help. That is, in the ICMP message, if I want to know what is the time, let's say मुझे पता करना है how much time a packet is taking from going to this place, then I have to send a timestamp request message. This is a timestamp request message. Okay, so whenever I'm going to send a timestamp request message, so as a response, so the receiver is going to send me a timestamp reply message, and in that timestamp reply message, he's going to put its own timestamp. Okay, somebody please. Okay, so what I'm saying, so in the timestamp reply message, the destination machine is going to send his own timestamp. आपको खुद का टाइम स्टैम्प स्टार्ट टाइम स्टैम्प पता है, so उसका रिसीव टाइम स्टैम्प नाउ you could able to know. So from that you can able to calculate how much time it has taken to reach at that particular date. So this type of calculation you can able to do with the help of this timestamp request and reply message. That is again a ICMP message. Okay, and then 17.0, this is an address mask request. If you want to know what is the address mask, network mask, so of a destination, you can also send a request of ICMP message with 17.0, and he can go and supply, send a reply message on top of it with 18.0. So to let you know what is the net mask of that particular end. So what is using. So this type of, this is some I say, this is some of the ICMP messages we discussed. There are others. So these are some of the important ICMP messages we just discussed to know. So how these ICMP messages are going to help us. So to carry out certain jobs at our end. Okay, everybody got an idea? Now, going back to that, let me see. So whenever this ICMP error message has reached here, again, so this originator, so whoever received this ICMP error message, he feels that there is something wrong in this ICMP error message. So while checking the checksum, he finds there is something wrong in this particular ICMP error message. So as a result, again, he's supposed to generate one more ICMP message. That is one more ICMP error message towards the originator, that is R2. Again, R2 is going to generate one more ICMP message towards source. Like this, if it is going to happen, a loop is going to form. Yes or no? And if ICMP error message ke liye, whenever somebody is receiving an ICMP error message, if there is something error in that, if he is going to generate one ICMP error message on behalf of that, again, so that is going to form a loop as far as the ICMP message communication is concerned. So that's why there is some restriction as far as generating an ICMP response message is concerned. Let's look into that. What are those limitations, or what are the restrictions on ICMP error message generation? Okay, ICMP error message. So generation. So that means when an ICMP error message has to be generated and when not to generate. Let's look into that. What's the first scenario we talked about? So ICMP error message should not be generated on behalf of an ICMP error message. ICMP error message. That means if somebody has received an ICMP error message and there is something wrong in that, then he should not generate one more ICMP error message on top of that. So because it might encounter into a loop. So that is not allowed. That is not prohibited. I mean that is prohibited. So that is not allowed. Second. Can anybody think of another scenario? Let's try to understood. Let's say this machine wants to broadcast a packet to this one. everybody in this network, this machine wants to send a broadcaster. Okay. Now, so whenever this is received at this, okay, so there is a destination port unreachable. The port is not reachable. So now, so everybody is going to generate a message, error message. Everywhere there is a port problem. There is a problem as far as the packet has received at its own end. So everybody is going to generate a ICMP error message on top of that. So if it is going to happen, so if the number of messages, number of devices, broadcasters is huge, in that case, number of error messages, ICMP error messages to be generated towards, so the network is very huge, which may be unpleasant, which may be so very, very congestive. So as far as the communication is happened. So that's why ICMP error message should not be generated so for a broadcast or multicast message. So be a broadcast or multicast type of message. ICMP message should only be generated for a unicast message, not a broadcast, not a multicast message. Because that is going to create a lot of ICMP error message may be flowing into the network, thereby congesting the network. So that is not allowed. Okay. And third point, one more thing you can think of also. So whenever you are sending a packet, let's say you are fragmenting the packet into number of fragments. The original packet has fragmented into 3 fragments. Okay. So original packet has been divided into 3 fragments because of the size of the MQ. So there is a fragmentation. So now this is the first fragment. This is the second fragment. This is the third fragment. While you are generating the packet and sending it to the router, let's say, so discard this packet. So because of some common reason, general reason, so that is applicable to all the fragments. Okay. In that case, so if the router 2 is generating error message for the fragment 1, is it necessary to generate the error message for fragment 2 and 3? Yes or no? Yes or no?
No, sir.
No. So that's why it is restricted. So that is, so only a error message will be generated for the first fragment, not the other fragment. So that's why, so IP datagram fragments, so except the first. IP datagram fragments, fragments, except the first. That is, a ICMP error message will be only generated for the first. Last but not the least, that I was talking about the application of ICMP. Let me talk about an ICMP application, that is trace route. That's everybody very interesting. Trace route. That is, if I want to communicate from one machine to another machine, what I'm going to do, I want to know what are the routers my packet is going through, so while traveling to the final destination. This is what I want to know at the source end. Okay. So what I will do, see, I generate a packet, I generate a dummy packet. Initially, I generate a dummy packet with a TTL value of 1 and destination port number. This part I will tell why. Destination port number, a unusual value, let's say -1. Unusual, which is not possible at all. I'll provide a destination port number, so which is not at all feasible. So that I will get. Okay, let's look into what is going to happen. So I'll tell this one later, but look into this one. So I will send a ICMP message is going to be generated with what? So type 11, code 0. If you remember correctly from that example, so type 11 means TTL has expired or time exceeded. So 11, that means with a what? It is going to generate an ICMP message with a type of 11 and guy. So now it got it. So then what it will do? So next time after this, it will increment the TTL value to 2. Very, very cleverly it is doing. It is incrementing the cleverly, so the TTL value to 2. So now the next packet is going to send with a TTL value of 2. So when it is going to reach at this router, it will become 1, TTL value decremented by 1. So now it is going to send it to this router. So at this end, the TTL value will be 0. Next time, so the TTL value will be 0 at the second router. So thereby, second router is going to again generate ICMP message towards the originator or not. So now originator could know about the IP address of this router. Okay. So then, so what is going to do? So going to do a TTL value of 3. So now it's going to send the next packet with a TTL value of 3. So at that point of time, so now TTL value will be decremented at this one, it will be 2. At this end, it will be decremented to 1. So then the packet will be delivered. So when the packet will be delivered to this destination, so my destination port number is -1. So what kind of ICMP message will be generated at this end? Destination port unreachable. Are yes or no? So that means with a type of 3 and with a code of 3. So final destination is going to generate a ICMP message with a type of 3, code of 3. And whenever the originator get ICMP message with a type of 3 and code of 3, he will stop. That means he knows all the IP address of all the intermediate routers. So by using this detail exceeded or time exceeded ICMP message and destination port unreachable. Are you getting my point? Is it understood? Yes or no?
Yes, yes, sir.
Okay. So this is how. So this is one implementation of ICMP by using ICMP. So only this trace route, and also we have already understood the ping command. So echo request and echo reply message. So by using the